We will now discuss the solution of a problem from the section three-dimensional geometry. The problem is on the concept of shortest distance between two straight lines given in the three-dimensional geometry. This question has appeared in the joint entrance examination main held on 27th June 2022 in the second shift. The given question is the shortest distance between the lines x minus 3 by 2 is equal to y minus 2 by 3 is equal to z minus 1 by minus 1 and x plus 3 by 2 is equal to y minus 6 by 1 is equal to z minus 5 by 3 is. We are given four options. Option A, 18 by root 5. Option B, 22 by 3 root 5. Option C, 46 by 3 root 5. Option D, 6 root 3. We are given two straight lines in 3 dimensions, required to find the shortest distance between them. That's our given question. We now discuss the solution of the problem in detail. We have two lines. The first line is this one, and the second line is this one. And the first line passes through the point 3, 2, 1 with the direction ratios 2, 3, minus 1. And the point, it passes through the point x1, y1, z1 is equal to 3, 2, 1. Let's call that as the x1, y1, z1 with the direction ratios a1, b1, c1, that's equal to 2, 3, minus 1. Similarly, the second is a straight line passing through the point x2, y2, z2 given by minus 3, 6, 5 and with the direction ratios a2, b2, c2 is equal to 2, 1, 3. So that is about the second line. And we have the formula for the shortest distance. The shortest distance is given by modulus of, it's a quotient. The numerator is a 3 by 3 determinant whose first row is x2 minus x1, y2 minus y1, z2 minus z1. Second row a1, b1, c1. Third row a2, b2, c2 by the denominator under the square root of b1, c2 minus b2, c1 whole square plus c1, a2 minus c2, a1 whole square plus a1, b2 minus a2, b1 whole square. Agreed. Agreed. So let's now compute the numerator, the determinant and the denominator in the next slide. So those are what we have done, and this is the formula for your ready reference I have given here. So the first, let's get into the determinant. The determinant x2 minus x1, y2 minus y1, z2 minus z1, first row, a1, b1, c1, a2, b2, c2, second row and third row respectively. And x2 minus 3 minus 3. And y2 minus y1, 6 minus 2. z2 minus z1, 5 minus 1. Agreed. and A1, B1, C1 is 2, 3, minus 1. A2, B2, C2, 2, 1, 3. So simplify. This is equal to the 3 by 3 determinant. First row minus 6, 4, 4, and the second row, third row remains the same. Now expand this determinant by its first row. It will be minus 6 into 3 3s are 9 plus 1 10 minus 4 into 2 3s are 6 plus 2 plus 4 multiplied by 2 1s are 2 minus 6. So expand by means of the first row. Simplify, you get minus 6 times 10 minus 4 times 8 plus 4 times minus 4. And you simplify all this, you will get minus 108. So that is the determinant value. Now next, the denominator. The denominator is under the square root of b1 c2 minus b2 c1 whole square plus c1 a2 minus c2 a1 whole square plus a1 b2 minus a2 b1 whole square. Now what are these? These are precisely, if you see this here, b1 c2 b2 c1 means it is the minor of this element, a1 one element, minor of a1 one element whole square. And that means what we have written is 9 plus 1. 9 plus 1. This will be 9 plus 1 whole square. This will be minus 2 minus 6. This will be minus 2 minus 6 whole square. And this will be 2 minus 6. And that will be equal to 9 plus 1 whole square minus 2 minus 6 whole square and 2 minus 6 whole square. Because we are squaring it, it is immaterial, and you take these things as it is and square it. And that will be equal to under the square root of 10 square plus minus 8 square plus minus 4 square. So on simplification, you will get square root of 180, that is 6 root 5. Now, the denominator value we know, the numerator and denominator values we have. So we have the standard, the shortest distance. Shortest distance is equal to the determinant by this one. Agreed. That's equal to the numerator. Mod of the numerator is minus 108 by the denominator is 6 root 5. On cancellation, you will get 18 by root 5. Let's look at our options. Our answer 18 by root 5 for the shortest distance appears against option A. Therefore, the answer for this question is option A. That is the detailed discussion of the solution of the problem on the shortest distance between two skew lines in three-dimensional geometry. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.